In homework 2.4a, you're having one of your first homeworks where you can use a calculator on all problems. In fact, it's needed to do some of them. So I'll go through as many of these as I have time for. I'll do one, determine y prime. So we need to use implicit differentiation to find this. You should be able to tell that automatically just because there's y's all over the place. So the derivative is going to be 2x plus, here's a product rule, the derivative of the first times the second, plus leave the first alone, times the derivative of y is y prime, plus the derivative of y squared is 2y times y prime equals 0. I need to solve for y prime, so I'm going to move these guys over to the other side, and I'm going to get negative 2x minus y. Here I'm going to factor out the y prime, and what's left over is x plus 2y. So y prime equals negative 2x minus y over x plus 2y. Great. Determine the equation of the tangent line. Equation of the line tangent to the graph is going to be y equals m times x minus x1 plus y1. You've got to have that down by now at the point 2, 1. So our point is going to be 2, 1. That's my x and my y value. And the slope is found. The slope of the tangent line is the derivative. And so I'm just going to plug in x and y. So y prime evaluated at the point 2, 1 is equal to, let's see, negative 2 minus 1 is negative 3. 2 plus 2 is, well, that's not right. When x is 2, it's negative 4 minus 1, which is negative 5. And then when I plug in 2, 1 here, I get negative 5 fourths. So the equation should be y equals negative 5 fourths, that's the slope of the tangent line, times x minus 2, because that's my x value at that point, plus 1. So that's the equation of the tangent line. And it says to draw this line on the graph. Well, at the point 2, 1, sure, the line is going with a slope of negative 5 fourths, so down by 1, 2, 3, 4, 5, over by 1, 2, 3, 4. It's pretty clear that's the tangent line. Yeah, that looks right to me. Okay, cool. All right. Use your tangent line to estimate one value of y when x equals 2.1. So when x equals 2.1, obviously we're not estimating this value right here. We're estimating the nearby value right here. And it's super easy to estimate. All we're going to do is plug in 2.1 into our tangent line. Negative 5 fourths times 2.1 minus 2 plus 1. So it's going to be y equals negative 5 fourths times 0.1 plus 1. This is, I don't know, I could use a calculator on it, but I guess I don't need to. It's negative 0.125, so it's equal to 0.875. I don't know, maybe I messed that up, but I don't think so. One value of y when x equals 2.1 is 0.875. Now it says use your tangent line to estimate one of the zeros. Well, the zeros from algebra 1 are the x-intercepts. Obviously, we're not going to use it to estimate this zero. We're going to use it to estimate this zero because it's pretty nearby. Well, how can we do that? When the tangent line is equal to 0, when the y value is equal to 0, that will be very near the x value that's equal to 0 on this slanted ellipse. So all I'm going to do is I'm going to use my tangent line, and I'm going to set it equal to 0. This should remind you of our, I believe it was our second homework of the year, had problems just like this. It's been a while since we've done it, which is why we brought it back up. I'm going to, instead of distributing, I'm just going to go ahead and use inverse operations. I'm going to subtract 1, and then I'm going to multiply by the reciprocal. So I'm going to multiply by negative 4 fifths. There's just some algebra 1 here. So I get x minus 2 equals positive 4 fifths. X equals 2 plus 4 fifths, which is 14 fifths. Or 2.8. Either way is fine. All right. It looks like my wife is telling me I need to go home soon. So I'll do one more problem. Let's do number 3. It says determine the linear approximation of f of 3.01 given that f of x equals this guy. Is your estimate an underestimate or an overestimate of 3.01? Prove using calculus. So, to find the linear approximation, that's another wording of saying find the equation of the tangent line. That's the linear function that very nearby a function will be an estimate. That's what we mean by linear approximation. You're using the tangent line. So the point that's nearby 3.01 that we're going to use is when x is 3. So when x is 3, y I need to find by plugging in is 27 minus 18 minus 2, so 7. 3 comma 7 is the point I'm going to use. That's because f of 3 equals 7. And the slope I need to find by finding the derivative. The derivative will tell me the slope of the tangent line. It's 6x minus 6, and I need f prime at 3. So that is 12. So the equation of the tangent line is going to be y equals 12 times x minus 3 plus 7. That is my linear approximation for f of x at x equals 3. And so the linear approximation at 3.01 I can find by just plugging in 3.01 here. Y evaluated at 3.01 is equal to 12 times 3.01 minus 3 is 0.01 plus 7. This just moves the decimal place twice, so it's going to be 0.12 plus 7, which is 7.12. And now I need to know if this is an underestimate or an overestimate. So this is a new deal. The calculus we're going to use here is brand new. We've never done this before. We said earlier that we know that something is concave up if it's an overestimate. Sorry, concave up if the linear function was an underestimate, and it's concave down if the function was overestimated. Well, what we're going to do is we're going to see, is the function concave up or concave down, using a brand new technique. To see if something is concave up means that the slopes are changing upwards. That's what bending upwards means. It's concave up means it's bending upwards, which means that the derivative needs to be increasing. Concave up means the second derivative is greater than 0. Similarly, concave down means that the function is bending down, the slopes are decreasing, which means that f prime is decreasing. That means that the derivative of the derivative, which is the second derivative, has to be less than 0. We'll talk about this more next class. Don't worry too much about it yet. But for now, it's really easy to see if the function's concave up or concave down. F prime prime is equal to 6, which is greater than 0. Because f prime prime is greater than 0, the function must be concave up. This is saying the slope of the slope is positive. The slopes are increasing, which makes it bend upwards. And so because f prime prime is greater than 0, f of x is concave up. So that must mean if the function is bending upwards, the linear estimate is an underestimate. 7.12 is an underestimate of f of 3.01. You could have also done this just by plugging in 3.01 into the original function, but that's not proving it using calculus. So this is a new thing we're going to be talking about coming up soon. That's all the time I have. I'm getting lots of messages from my wife that I need to go home because it is 8:15 on a Sunday.